So we're going to introduce you guys to something called series today. Our main focus will be on some kind of special notation called sigma. So we'll talk about what a series is first, then we'll talk about this sigma notation, then we'll talk about how to use it. Alright, so what is a series? Go ahead and copy down this slide, please. So here's our beginning question here. What is a series? A series is when you take a sequence like 2, 4, 6, 8. It's arithmetic. It's going up by 2s. When you take a sequence and you add everything together. So instead of 2, 4, 6, 8, it's 2 plus 4 plus 6 plus 8. That's a series. Okay? So therefore they share a lot in common with sequences, and we'll be using a lot of the stuff we learned last time to do it. Alright, let's go ahead and proceed. Copy down this slide, please. Alright, so this is called sigma notation. The little symbol here in the middle is the symbol we call sigma. And what that means in math is we're going to be adding. So the question is, what are we going to be adding? And that's what the rest of the stuff tells us. This is going to be where we put our nth term formula right to the right of it. So that tells you we're going to be adding what the nth term formula gives you. What does the nth term formula give you? It gives you all the terms of a sequence. If you plug in 1, it gives you the first term. If you plug in 2, it gives you the second, third, fourth, fifth, so on and so forth. So now it was asked earlier, how do you know where to start and where to begin? Are we starting with the first term and ending on the fifth? Well, that's what the top and bottom numbers are telling you. The bottom number is telling you what term we're going to start with. The top number tells you what we're going to end with. So for example, if I had a 1 down here and a 5 up here, what I would do is I would plug 1, 2, 3, 4, and 5 into my nth term formula, so I'd get 5 numbers, and then I would add them all together. That's all it's telling us to do. The reason we have sigma notation is because these strands are really long numbers, and this is a way to condense everything. So let's go ahead and we'll do a few sample problems. Go ahead and write down your directions and number 1, please. So all this is going to be, guys, is decoding math language into something that makes sense to us. So here we go. What this is telling you is we're going to take this formula, we're going to plug 0 in, then 1, 2, 3, 4, 5 until we get to 6. And once we have those numbers, we're going to add them all together. So that's what the sigma is telling us to do. Let's go ahead and see what that means. Let's do it. So first of all, we need to find the first term, T1. Or not the T1. What term do I start with here? The 0th term. We haven't really learned about that. But we're going to start with the 0th term, which means you're going to plug in what for I? 0. So it's 0 plus 10, which is 10. So there's the 0th term. Let's go ahead and find the first term now.
11.
It's 11, right? And the second term? And as you guys can see, it's just going to go up 1 each time, right? So can I just skip the math work? T4 is 14. T5 is 15. And T6 is 16. So that's T1 through T6. Notice I started at the 0th term and I worked my way up to the 6th term, and the nth term formula helped me get each term. We have the numbers 10 through 16 increasing by 1. Alright, now we're not done. We haven't used this symbol yet. What does the symbol tell me to do? Add them all together. So now this is a sequence over here, 10, 11, 12, 13, 14, 15, 16. But we can turn it into a series by adding them all together. So let's go ahead and do that real quick. So therefore, the final answer, once you add all those together, is 81. And that's what that equals. Oh, 91, sorry. Let me fix that. 91. I don't know why I got the 81 stuck in my head. 91. Alright, go ahead and write down number 2, please. Okay. Now I'm just going to give you a second example to show you the importance of order of operations here, and some of the nth term formulas can get kind of funky. So just thought we'd look at a few. So I'm going to start by plugging in what here? 1, because that's my lower limit this time. And I'm going to work my way up to what? 4. All right, so let's do it. Let's do T1 first. So that means I'm going to plug 1 in 2 spots, here and there. So that gives me -1 to the 1 power multiplied by 5 times 1. All right, well, what's -1 to the first power? It's -1. And -1, 5 times 1 is 5. And so -1 times 5 is -5. So there's your first term, right? I'll just put that over here on the right side so we can go horizontally like we did in the last one. All right, let's go ahead and find the second term. So I'm just going to replace the j with 2 now. All right, well, what's -1 squared? Positive 1. -1 times -1 is positive. And 5 times 2 is 10. And 1 times 10 is 10. T3. -1 to the third power multiplied by 5 times 3. What's -1 to the third power? -1 and 15 makes... Okay, now at this point, I think we could probably discern a pattern. What's going on here? We're going up by 5, and the sign is changing, right? So the next number is going to be a positive number, and it's going to go up 5, so it'll be positive 20. So after you guys see a pattern, you can probably just start skipping the math and just follow through with the pattern, all right? But but we're not done. What do I need to do now? Add them all together, because that's what a sigma is all about. Make it a series. So let's see what we get out of that. 10? I believe it's positive 10. So it equals 10. There's our answer.